All right, in this video we're going to be continuing with where we left off in the first part, or day 1 of lesson 3.2. So specifically in this video we're going to be looking at how we can be using story problems when we're adding, subtracting, multiplying polynomials. But to start out with, let's look at a warm-up problem. So let's look at this one. So why don't you guys go ahead and look at each of these. So we have two where we have to simplify them, and then Mark is back. Mark, I think, is having some troubles with math. And so what you're going to do is you're going to look to see, has he finally gotten a problem right? So we want to look to see if when he multiplied those together, did he get the right answer? And if not, where did his, what would be the correct answer? So go ahead and pause this video and hit play when you're ready to check to see if you've done this warm-up correctly. All right, let's see how you did. So for that first one, when we're adding polynomials, remember we could just combine like terms. We see the 15x and 6x. Those we can combine to be 21x. And then 2y minus 5y, those we can combine to be negative 3y. Now for the other one, we're going to multiply those together. So we have, you can use that box method. So we'd have 4w minus 3 times 3w squared plus 2w plus 3. And so when you add those together, we do get some like terms that are diagonals this time. And you end up getting 12w cubed minus w squared plus 6w minus 9. Make sure your answers are in standard form. All right, and lastly, poor Mark got it wrong again. He got the last term right, but everything else is wrong because x times 2x is not x squared. It should be 2x squared. And then the middle terms, he must have forgot about the minus x or something because he has plus 10x when 10x minus x would be 9x. So that's the mistakes that he made. So it should be 2x squared plus 9x minus 5. All right, let's look at a story problem. So that's what we're going to be focusing on today. So here it says, Carolina makes wind chimes to sell at the local street market. As Carolina produces a greater number of wind chimes, she can lower the price per unit. The function v of x equals 488 minus 2x relates the price v to the number produced, x. The cost of making x wind chimes can be represented by that equation. All right, there's a lot of information there. Let's first talk about this idea of how to make a profit. This summer, my wife and I did a garage sale, and our kids wanted to have a lemonade stand. But instead of doing a lemonade stand, I convinced them to instead sell soda pop. So they were selling cans of pop at $1 a piece. Now, I wanted to teach them what it's like to run a business. So they didn't get to keep all their money. I explained to them that that pop cost us money. And so they would make a profit after they considered the revenue that they made, the money that they made at the garage sale selling the individual cans, and we would have to subtract how much it cost for each of those cans. And so each can cost us about 20 cents a piece. So they're making some good profit, and they actually made some really good money selling ice cold pop on a really hot day. So a little side note, if you and your family ever have a garage sale, try to convince your younger siblings, if you have any, to sell some pop, because kids or adults are suckers for kids selling pop on a hot day. So anyhow, so if you take the revenue, how much you make in sales, minus what it costs to do whatever it is that you're making, that represents your profit. So that's what we're going to do here. So that function, the 48 minus 2x represents the number of units sold. Okay, so that function there represents, that represents the price. That represents the price. The number of units sold is just x. So what we're going to do is we're going to have to multiply x times that equation that represents that price to figure out what the revenue would be. Okay, so for example, with my daughters, if they sold 50 cans of pop at $1 a piece, that's $50. But then we have to subtract the cost. And so we're using that function that represents the price times x. We don't know how many she's going to sell of her wind chimes. And that's going to represent the revenue. And the cost is 12x plus 64, so we're going to have to subtract that from the revenue. So that's what they're showing here. So we would take and combine those. So we'd have the 48 minus 2x times x, that would represent the revenue, minus the 12x plus 64, which would represent the cost. So we're going to represent that now with this function. So to simplify this, we would first we'd have to distribute the x through. So we'd have x times 48 minus 2x. So we'd have 48x minus 2x squared. We distribute the x through. And then we're going to have to distribute the negative. So then we'd have minus 12x minus 64. And now we can combine like terms. When we combine like terms, we would get, and again, putting it in standard form, we get negative 2x squared. The 48x minus 12x, we can combine to be 36x minus 64. So that function would represent her profit function. It would be negative 2x squared plus 36x minus 64. So you can see behind me, and I'll kind of phase myself out here so we can see more of the graph. But you can see behind me, this would represent the graph of the function, with the 9 and 98 would represent the maximum price or maximum profit. So if she sold 9 wind chimes, she would make a profit of $98. That's after taking consideration the cost and everything. So that would represent her total profit would be $98. That would be the maximum. Anything after that, for whatever reason, she would actually lose money. Okay, so her maximum profit would be selling 9 wind chimes for a total of $98. All right, so now we have Carolina's profit function is represented by the graph that we just looked at. And her neighbor, Keo's profit from selling X decorated flower pots can be modeled by the function shown. So Keo has is selling flower pots, and that revenue, his revenue is X times X minus 3 times 10 minus X. Now what we're going to do is we're going to find the y-intercept of each function to figure out who would lose more money if neither person sold any items. All right, so we can see, or we can even figure out from the first function, I can't remember, from Carolina, that her y-intercept would be negative 64. Okay, so if you were to go back and look at that equation, remember we had minus 64. So if she sold 0 wind chimes, she would owe $64. And the reason for that is because there was a cost to her startup. Okay, so she had to pay some things up front. So before even selling anything, she's already owing $64. That's what that means for her profit. Now with Keo, if you were to put 0 in for X there, you would find that for Keo, he would have 0 startup, because 0 times 0 minus 3 times 10 minus 0 would end up just being 0. So there was no startup fee for Keo. So he does not lose any money. So as far as comparing the y-intercepts, right now Keo, right off the bat, is going to make profit. Doesn't have to worry about anything. Where Carolina, she starts off owing money, owing $64. Now we're going to interpret the end behavior for both of these. Now we can see the end behavior for Carolina pretty easily. We can see that both ends go down. So as X approaches infinity, because that's really what we care about, is because X represents the number of wind chimes that she sells. So as she sells more, the profit is going down. So that's not a good thing. I wonder what Keo's profit function looks like. So those are all of what we just talked about. Okay, so now let's look at Keo. So for Keo, we're going to have to figure out, well, what does his look like in standard form? So we're going to multiply X times X minus 3 times 10 minus X. Well, let's start by multiplying X times X minus 3. That's going to be a lot easier. So then we'd have X squared minus 3X times 10 minus X. Well, now what we're going to have to do is we're going to have to do that box method. So I'm going to take and multiply X squared minus 3X times 10 minus X. Now we could leave it like that. Personally, I would switch it around to write negative X plus 10. But if you don't want to worry about making some common mistakes, you can just leave it like this, and we'll put it in standard form in just a second. So when we multiply these together, we would have 10x squared. X squared times negative x would be negative x cubed. Negative 3x times 10 would be negative 30x. And negative 3x times negative x would be a positive 3x squared. So now our like terms are right here and here. So it's a diagonal, just a different diagonal, because we had the order of that other expression kind of backwards there. So our answer is kind of backwards. So when we put this in standard form, we would have negative x cubed plus 13x squared minus 30x. So what's important there is, remember, that leading coefficient. So the leading coefficient is negative. So that means the right side of the graph is also going to go down. Okay, so even though the left side, so they're going to go in opposite directions. So it doesn't matter if the left side of the graph is up. What matters is the right side of the graph would be going down. So both of these graphs, neither of these functions are great over time. Because over time, what both of these graphs mean is that as x approaches infinity, y is going to be approaching negative infinity. So over time, they're going to both lose money. But at the beginning, Keo has a better function because he has no starting fee. Now, the one thing that they don't ask for this one is they don't ask what's the maximum value, what's the most that Keo could make. And we don't know that. So that would be the main factor as far as deciding which one would be the better one. All right. So I want you guys to try this one on your own. So I want you guys to look at, so here we have this profit function, function f. So you can see from that what the y-intercept would be. We can see where it's negative. We can see where it's going to be increasing over time. So I want you guys to identify where the y-intercept would be and the end behavior of that function with this function g of x. So the function g of x is a different profit function where we have x plus 1 times 5 minus x. So I want you to multiply those together so you can easily see where the y-intercept would be and what the end behavior for that function would be. And then we're going to figure out which profit function would be a better one in the long run. So why don't you guys pause this video and find those pieces, and we'll discuss what your answers mean after you find those. All right, let's see how you did here. So for that first one, so for f of x, again, we can easily see that the y-intercept for that would be 0. We can see that as x approaches infinity, the graph is going to be going up. So y is also going to approach infinity. So that's important. Let's look at function g of x. Okay, just leaving it as x plus 1 times 5 minus x, it's hard for me to see what the end behavior is going to be. So if we multiply those together, again, using that box method, we would get negative x squared plus 4x plus 5. Now, it's much easier to find the x-intercept there because the x-intercept is just going to be 5. I'm sorry, the y-intercept is just going to be 5 because you can find that by putting 0 in for x. That whole beginning part would disappear, leaving us with just 5. So that last number there is our y-intercept of 5. So the first function, so let's just stop there and compare y-intercepts. The first function has a y-intercept of 0, meaning when they don't make anything, there's no startup fee or anything off the bat, so we're starting with $0. But the second one, interestingly enough, when we don't sell anything, we're starting with a profit of $5. So second function has a better starting spot. Okay, so at the beginning, right off the bat, function g is a better revenue. But let's see what happens over time with function g. With function g, we can see that since our that leading coefficient is a -1, we know that in the long run, the profit is going to be decreasing. It's going to approach negative infinity. So the right side of the graph is going to be going down, where with function f, the right side of the graph is going up. And we can look even more specifically. I'll fade out my graph here, or fade out my video here. But we can see, we can find the x-intercepts. You might be wondering, well, how did you find those x-intercepts? Remember from last chapter, we can set, it's in factored form, x plus 1, 5 minus x. It's in factored form. We can set each of those equal to 0 and solve them. So when I set x plus 1 equal to 0 and solve it, I'd get an x-intercept of -1. When I set 5 minus x equal to 0 and solve it for x, I would get an x-intercept of a +5. So I would have an x-intercepts at -1 and 5. And I know that this would be a parabola pointing downwards with the y-intercept of +5. So I have enough information to sketch a graph and see what it looks like. So with the second function, the only time that he's making a profit, he or she's making a profit, is when they sell 0 product to 5 items of whatever it is. So between 0 and 5, they're making a profit. But after selling 5 items, after that, they're losing money, which I know seems kind of weird. Where for the other function, function f, between 0 and maybe 5 or whatever that y-intercept would be there, we're losing money. But after that, from 5 to infinity, all of that is 100% profit. So in the long run, function f would be a better function. But in the short scheme of things, between 0 and 5 items, actually the second one would be better. But in the long run, I think function f would be a better revenue. Function f would be a better situation. So that's how you can use that to kind of interpret and be able to make a decision. So in summary, this summarizes what we did yesterday, not so much what we did today. But remember, this is short. This is a good illustration of how the book taught how to multiply. When you look at that last one, how to multiply those, you can see it's a lot more complicated than just using a simple box. So anyhow, with that, I hope you have a better understanding, a better grasp for what we're doing in this lesson 3.2.